63.66 mass percent. Okay. So moving on to a new example. Usually the mass percent and the percent composition, the way it comes in handy is if you've got some kind of unidentified compound that you need to do some analysis on and figure out what it is. So here's an example that's like that. We've got an unidentified compound which is sampled and studied. It's determined that the sample has a total mass of 35.8 grams. Sample contains 30.1 grams of carbon and 5.70 grams of hydrogen. So what is the percent composition of the compound? In other words, summarize the mass percent of the compound of the compound for all the different elements that are in that compound. Okay, so we could start with the carbon. So the mass percent for the carbon is going to be equal to, okay, so we have 30.10 grams of carbon. Divide that by 35.8 grams, which is the total mass of the sample. Okay, and multiply the whole thing by 100%. And that's going to give us 84, let's say I'll round it here, 84.1%. So the mass percent of carbon is 84.1%. And then for the hydrogen, okay, that's going to be the 5.70 grams divided by the total mass of the sample, 35.8 grams, and then we'll multiply the whole thing by 100%. Okay, and if we do that, okay, that gives us 0.159 times 100%. 15.9%. Okay, and that stands to reason because we've got 84.1% here, 15.9%, add those together, and we end up with our 100% of the sample. Okay, so another way we could have come up with a mass percent of hydrogen could have been just by simply subtracting from 100% the 84.1% which we had for carbon. Okay, so there's our percent composition for this unidentified compound. Once you have this kind of information, then you may be able to put it together with some data from tables and figure out what that material actually was. Okay, so there we go. We can calculate the mass percent from a sample when we know the masses of the individual elements. We can also calculate the percentage composition of a material if we know its chemical formula. Okay, so here's an example. Sodium carbonate. Pretty straightforward to calculate its percentage composition. We'll just do it like so. Okay, so for this compound, sodium carbonate, we've got 2 sodium ion atoms. Actually, they're ions, right? Connected with the carbonate ion. But within the, I guess this is a compound, ionic compound. Within this compound unit, we're going to have 1 carbon, and then we've also got 3 oxygens. Okay, so the molar mass of sodium is, if we look it up in the periodic table here, is 22.99. Okay, so I'll just put it in grams per mole, which you're familiar with now. Okay. Carbon, its molar mass, its elemental molar mass is 12.01 grams per mole. Okay, and oxygen is 16. Okay. So, if I have 1 mole of sodium carbonate, that means that I'm going to have 2 moles of sodium atoms within that 1 mole of sodium carbonate. It means that I'm going to have 1 mole of carbon atoms within that sample, and I'm going to have 3 moles of oxygen atoms. So, to get the total mass of 1 mole of sodium carbonate, I'm going to take the molar mass of sodium, multiply it by 2. I'm going to take the molar mass of carbon, multiply it by 1. In other words, just leave it the same. And then I'm going to take the molar mass of oxygen and multiply it by 3. Okay, so I'll add all of those things up together after I multiply them through. So 2 times 22.9. Okay, so this one we get 45.98. This one here we're going to get 12.01. And this one here we're going to get 48.00. Add them all up, we get 9, 9, 5, carry the 1, 8, and 10. So 105.99. Basically, what we've just calculated here is the molar mass of sodium carbonate. Okay, so to find the mass percentage of sodium within sodium carbonate, what I need to do is basically just divide the 45.98 by the 105.99. To find the mass percentage of carbon within sodium carbonate, I would have to divide the amount of mass that comes from carbon, so the 12.01, divide that by the 105.99, the molar mass of sodium carbonate. And then finally, to find the mass percent of oxygen, I'm just going to divide the mass that's contributed by oxygen atoms and divide that by the mass of the molar mass of the entire compound. So let's do all those things now. So the mass percent sodium can be equal to 45.98 divided by 105.99. Okay, and that comes out to 43.4%. The mass percent of carbon is going to be equal to 12.01 divided by our 105.99 multiplied by 100%. And that comes out to 11.3%, and the mass percent of oxygen is going to be equal to, let's see, 48 divided by the 105.99 times 100%. And that works out to 45.3%. Okay, so the three values are 43.4%, 11.3%, and 45.3% for our three mass percents. Okay, add those three things together and they should get something close to 100%. 43.4 plus 11.3 plus 45.3 gives us 100%, lo and behold. Oops. Okay, so those three percentages represent basically the composition of sodium carbonate. So sodium carbonate is 43.4% by mass sodium, it's 11.3% by mass carbon, and it's 45.3% by mass oxygen. Okay, thank you for listening to my video, and we'll see you in class.